topic I want to talk about is going to be exactly something from the book. They were talking about area, and they also talked about perfect squares. Huh? Yes. Because if you notice, when they went to the castle walls that were kind of covered up, the entrances that were covered up with the stones, one was a actual perfect square. And how do you discover a perfect square? You discover the perfect square by having when your length and your width are exactly the same. So I have some examples I want to show you in just a few moments. So I'm ready to switch my camera angle, and we're going to show you real quick. I'm going to try to make as many as I can because I actually have a large bucket of squares tonight. About perfect square is they showed two of them in there. They did a 3 by 3. You're able to make a square because whatever you have on one side, you have on the other side. So your length times width is going to be here a 3 times 3. And of course, 3 times 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now, the next perfect square would be a 4 by 4. 1, 2, 3, 4, 1, 2, 3, 4, which will be 16. Okay? So that's what we've been talking about. So let me see, can I slide this over here? And I'm going to slide this over here. Because these are the two that they showed in the book. But of course, with a perfect square, we can do a 2 by 2. Okay? And if we do a 2 by 2, that's going to give us a total of 4. Let me get it on the screen for us. So somebody asks you, what is a perfect square? This is what a perfect square looks like right there. And that's what it looks like as a picture. That's awesome as a picture. So I'm going to try to match the colors up. For my blue, this is going to be 2 times 2 equals 4. 2 times 2 equals 4. Because what am I talking about here? I'm talking about L, length, times width is equal to the A. Because that's what they were talking about the entire time. They was talking about length times the width gives us our area. So that was one of the key things that I was talking about. And my next one, I didn't bring it. Wait a minute. For my green one, this would be a 3 multiplied by 3. Same thing, length times width, which is going to give us 9. Okay? So we're still talking about the area model, but right now I'm doing perfect squares. Why? Because the same distance on the length and the width, and that forms an actual square, not a rectangle. And then I did a 4 by 4. Okay. So length times width, okay, or factor times a factor equals a multiple or product. We're still focused on our multiplication facts right here. That's all we're doing. All right, so can I repeat the pattern again? I'm going back to blue. So that means we can do 5 times 5, or 5 multiplied by 5, which will give us 25. And we can also make a 6 by 6, length times width, which will give us 36. And we're going to see if we can make this last one right here. 7 times 7 equals 49. Because all we're doing is we're actually taking the square tiles. Because when we talk about area, we're talking about using square tiles. And so this is what we're doing right here. So the next one I want to try to make is a blue, a 5 by 5. So give me a moment to see what I can do with that. One, two, three, 4, 5. So what does that mean? I'm looking for 5 rows of 5. Looking for 5 rows of 5. So right now I have 2 rows of 5. Have to get some more blues. All right, this is 3 rows of 5. Not a square yet. That is 4 rows of 5. Depends which angle you're looking at. Trying to get rid of some of these spaces right here and close them up. But in theory, folks, this is a square. Why? Because the length and the width are the same thing. So yes, we just made us a what? A square. This is a 5 by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And of course, we said a 5 by 5 is 25. All right, let me see how much room I got. I want to use my green and make a 6 by 6. There's one column of 6. 1, 2, 3, 4, 5, 6. Man, I love doing this right here, man. The cool part is we're still talking about area and perimeter. All right, so at the top now I have 1, 2, 3, 4, 5, 6. Now I gotta go down and fill everything else in, and once I fill that in, that should give us another square, which should be our 6 times 6, which equals 36. Everything's not tight as I want it to be right now, but that's all right. And this is a cool activity that you can do in class with your teacher, doing your station time or doing your time that you need to do, making perfect squares, making area models. And as I told my students today, guess what? All this is still considered to be multiplication. So we're showing multiplication using a array or an area model. I'm trying to close some of these gaps right here. I done messed up. Give me 1 second, folks. All right, so that's my green one right there. So now I have a 5. The blue one is a 5 times 5 equals 25. And the 6 times 6 equals 36. All right, I want to try one more if I can. Let me see, and we'll move him up. Let's see, how does that look? Cool, still look decent on camera. All right, I want to try this other one right here. We have a little bit of time left. And we want to try this right here. One, two, three, 4, 5. Uh-oh, I think we got it. 6, 7. Just enough, folks, just enough. What I'm creating right here, I'm doing a 7 by 7. And of course, length times width. The length is going to be 7. The width is going to be 7. And our multiplication factor is 7 times 7, which will be 49. So I'm working with this right here. Give me a few moments as I build this. So tonight I get to be a builder tonight. So I was able to use manipulatives to show modeling. Once again, the blue is a 6 by 6. Length is 6. The width is 6. The green one is, I'm sorry, 5. Blue is 5. I made a mistake. Green is 6. 1, 2, 3, 4, 5, 6. So I have a 5, 6, and I'm working on my 7th one right now. So bear with me. All right. Those that are with me right now, tell me what your favorite part of our story was tonight. So go ahead, put it in the chat for me real quick. What was your favorite part of the story? Because my 1, 2, 3, 4, 5, 6, 7, my favorite part of the story was the sea serpent. And how they claimed that the sea serpent was so big and bad, he kept popping out the water and scaring them. But guess what? At the very end, guess what? He turned out to be very gentle. And I think in that last picture we saw, he was at the celebration, and I do believe he was actually smiling. So that was actually awesome. So that was my favorite part of the story, talking about the sea monster, which really wasn't a monster. And the whole time, he was the key. Literally, he was the key. All right, I'm still building right here. Right now, I'm having 49 pieces here because I'm making my array. My length and my width are going to be the same. So this is what we just built. Wow. All right. So now we have blue 5 times 5, which is 25. We have the next one, the green, which is 6 times 6, which is 36. And now we have our 7. 7 times 7 equals 49. And guess what, folks? We're going to see, can we continue this pattern? Let's continue this pattern here. And we're going to push ourselves up here. We'll come after 7. We're going to do 8 multiplied by 8, which is going to be 64. Ooh. All right, we're going to try another green one, which will be 9 times 9, which is 81. And we're going to try the big boy tonight. We'll make us a hundreds chart by doing 10 multiplied by 10, which is going to give us 100. Woo! All right, so bear with me. I'm going to move him to this side over here. I'm going to move this one over here. All right, I'm going to keep what I have right here, and I'm going to add to this one right here. Once again, for our blue, it's going to be an 8 by 8. And right now I already have 1, 2, 3, 4, 5, 6, 7, 8. Okay? I'm going in my column area, however you're looking at it. One side is 8. To make it a perfect square, the other side has to be 8. Let me see how far I can go. I'm going to have to go this way. 1, 2, 3, 4, 5, 6, 7, 8. All right, so I'm going to fill in the pieces right here. And let's see what's going to happen here. Look like I got enough squares to do it, so just bear with me. And I like how the circumference series is actually how they infuse the math into such a story about the Knights of the Round Table. So that's another history maker right there, talking about King Arthur. Because the way they're talking about is circumference is one of the Knights of the Round Table. And so he is close to the king, and everything is his wife and his son Radius. His wife, of course, Circum's wife is Lady Di of Amateur, and his son is named Radius. So it's amazing all the adventures they're having at their castle. So it's awesome. So I encourage you. I'm not sure if I'm gonna be able to read all of them, but I encourage you to go take a look at the circumference series. I actually even recommend you putting that in your library, putting that in your personal library. That's why I went ahead and brought the books, because like I said, I really thoroughly enjoy and actually have been enjoying reading these books over the past 2 months, because I always like it when I'm able to combine two things, combining reading, or we combining literature with mathematics. And for my teachers out there that's watching, there's a whole lot of different things that you can do with this and combine it. Talking about author's purpose. Okay, and of course this one was to entertain. The purpose of this one was to entertain. So I enjoyed it, and hopefully you enjoyed it too. Got 2 more blocks here. Let me check and make sure I'm on track and make sure I did what I need to do. This should be our 8 by 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8 will give us 64. So I had to use 64 blocks here to make this here. But of course, guess what? It's still considered to be a what? A perfect square. Okay? So I'm going to have to get rid of that real quick. So once again, I have 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. We're going to try to get our 9s in. So we're going to see right here. Okay, all right. My producer just flipped it all out on me, and I can work with my greens right now. And we're going to see what we can do with that right now. Oh, wow, okay. Ooh, I got an awesome cameraman, awesome producer. Giving another shout out. So what we're going to do here, we're going to add to this one here, so we can create the 9s. So I got 1, 2, 3, 4, 5, 6. 7, 8, 9. So we're still on the screen right there. And let me make sure I can go the opposite way. 1, 2, 3, 6, 7, 8, 9. Yes, perfect. So I can fill these in right here. What are you doing, Mr. Jones? Oh, I'm having fun with tiles, square tiles, folks. And we're talking about perfect squares. And right now I'm building, I need 81. Need 81 total green blocks right here. And with these 81 total blocks, I am making a perfect square. I'm making an array, which should be a 9 by 9 when I finish building it. That's why I enjoy doing this show, because these are the things that I can only dream of doing within the classroom. Taking the time to actually do the perfect squares out like this. So what I like about this as a teacher and to share with all my other teacher colleagues, they can play this like maybe during lunch. Play this during a time where they can show them what it actually looks like, because you may not have time in the classroom to, you know, build all of these. But one key thing is there are a lot of visual individuals out there that this helps out, so they can see what a 9 by 9 looks like, what a 10 by 10 is going to look like, what does that 8 by 8 look like. So it's just amazing, and I get to show off some of my square tile manipulatives. So like I said, once again, I encourage you as the student, those that are watching me, ask your teacher, are you able to do this during your time? So we're doing what we need to do best. Almost there. It's building. And you know what else too? This is very relaxing. This is very relaxing. Being able to put these tiles here like that. And going to finish this up here. And I do believe we got time. We're going to attempt to make the 101. And they call this a perfect square. Why? Because the length and the width are the same. When you have your length and your width the same, that is what's going to happen. When your length and width are the same. Going back here to our board, we did 8 times 8 is 64. 9 times 9 is 81. We did before, I showed you 5 times 5 is 25. I showed you 6 times 6 is 36. And I showed you 7 times 7 is 49. So we're going to see what we're able to do for this last one right here. I'm going to see what we're able to do. Okay? So let's see what we're going to do. See, can I get this up here? Oh, yes, I can. And what the last one that I'm going to be making is a 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 right there. And see, can I go this way? 1, 2, 3, 4, 5. Uh-oh. 6, 7, 8, 9. He's off. We'll squeeze him right there. Yeah, I got quiet for a minute there. I was counting. Thank you for your patience with me right here. We are attempting to build using. I need 100 tiles for this one. Good gracious, I used all these tiles tonight. So I encourage you to do the same. And why am I using 100 tiles? Because I'm doing a 10 by 10. And I'm excited because I actually had enough tiles to build all of these. I done got excited. My math specialist gave this to me at school before I left. It's a whole bucket of square tiles. I got real excited. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, 100 total tiles. Thank you for bearing with me. Right now we're building a 10 by 10, which is going to be a total of 100 tiles. And once again, this is the last perfect square that I am going to be doing for tonight. Thank you for those that's sticking with me. Almost there. And then we're going to be out of here. I want to thank each and every you for joining us tonight. As always, I want to give a shout out to Mr. Norman Washington for allowing me to come into his studio every Tuesday night at 7 o'clock for Math Talk with Mr. Harvey Jones. I'll be back again, and I will be reading another circumference story. And so look out, tell a neighbor, tell a friend about the great things that we were doing today. And I'm excited. And guess what? I just finished my 100 tiles, and that is a 10 by 10.